Hi, good evening. This is a third part of Cuckoo Search algorithm. As promised, this is a practical example or simple example of Cuckoo Search algorithm, step by step, how we are going to solve an optimization algorithm, for example, minimization or maximization of any task using Cuckoo Search algorithm step by step. So, by the way, we use Lévy Fly. This is the original version of the Kiko search. So the original version, we have Lévy flight. Imagine if we have this objective function. If we have this objective function, which is fx1, x2, um, x1 square, and x2 square. So it has two dimension, x1 and x2. Problem with two dimension, you might have problem with many dimension. Kiko search update equation, it will be the next solution equals the current solution plus alpha multiplied by Lévy flight. Alpha is the step size, as we said in earlier class, and L is Lévy flight, which can be found randomly. Now, here, Lévy flight formula, L equals U over absolute value of V to the power 1 over B, 1 over beta, 1 over beta. So, first, how we find U? U equals approximately normal distribution of between 0 and variance from the standard deviation. So normal distribution uh, between 0 and variance. Now, how we can find variance? Variance can be found by this equation, which is um, which is tilde, that tilde, this one, tilde, that symbol is tilde. That tilde means factorial of for example, if we have five, tilde of five, so it means that four factorial or factorial of four. So five minus one, four factorial. It means 4 multiplied by 3 multiplied by 2 multiplied by 1. So 4 multiplied by 3, 12 multiplied by 2, 24, and 24 multiplied by 1, it's 24. So that's the factorial of this number. Now, so 1 plus beta, beta can be found here, 1.5, and 1 plus 1.5, so it's 2.5, for example, and then 2.5 minus 1, the factorial of it. So that's how we find a tilde. So this is the equation of variance. So the variance will be found, will be plugged here. You find U, U will be plugged here, and V, you can find it from here, which is normal distribution between 0 and 1. Here, if we have three solutions, x1, 4 by 1, x2, 2 by 3, x3, 5 by 2. That's x1 and that's x2. So you have x1 and x2. So x1 is 4 for the first sample, x2 is 1, uh, uh, x2, solution 2, 2 by 3, x1 is 2, x3 is x2 is 3. So the best, we will plug them into the equation, this equation, its solution. Uh, so 4 square plus 1 square, 4 square 16 plus 1, 17. That is 17. 2 square, it's 4 plus 6 square, 3 square, that's 9. 9 plus 4, 13. And 5 square, 25, plus 2 square, 4, 25 plus 4, 29. So the best solution is this one. So that's the best solution. That's minimum solution. We take the minimum of this. So that's initial iteration for nest 1, x 4 and 1. We will find U1, V1, U2, V2 for uh, first solution. So L1 we will find it from the U and the formula of L. This is how we found the result. That's 1.5 beta, and V is zero point 0.5, U is minus zero point 0.8. So first L found. Likewise, second L also will be found. So it will be 0.667 and 0.266. So that's the L1 and L2 is found. Now we plug them into update equation or position. X new equals the current X, the current solution 4 by 1 plus zero point 0.5 multiplied by Lévy. And Lévy, you have Lévy 1 and Lévy 2. So this is Lévy 2 and this is Lévy 1. This is Lévy 1. This is Lévy 1. This is Lévy 2. So now we find this result. So that's x1 new. So x1 is this one and x2 is this one. So plug them into x1 square plus x2 square fx1 x2. So this square 12.6. Now let's check whether this solution is yeah. So for the next nest x2, likewise we find u1, v1, v2, so that we can find L1 and L2, two Lévys. That's how we found L1. L2 also found. Now we plug them into the equation. We will find 1.924, 2.7. Plug them into fitness function, x1 square plus x2 square. So that's how we get it. So we find this one 11.04, which is very little, uh, minimum. So this it could be the best, or we consider it as the best. Now we go with the X3, 5 by 2. If I go by to my solutions here, so that's 4 by 1 we did it, 2 by 3 we did it, and 5 by 2 we did it. So here we will check the x2 we did it, x3 now 5 by 2. We have u1, u1, v1, u2, v2, so that we can get L1 and L2, L1 and L2. Now we plug them into L1 and L2. We found that's the results. Plug them into update equation. That is L1 and L2. That's L1 here, and this L2. This is alpha zero point 0.5. This is current solution 5 by 2. So we'll find 4.303, 2.15. Plug them into equation, it will be 23.6. Now here, result has been changed, 12.6. This is in this iteration, end of iteration. This is less than that we had it. X2 as well, we had less than that we had it. So has been changed. And X3, it is 23 again, it has been changed. So you can see three solutions are improved, but the minimum is 11. That's the minimum. That's the minimum. So this will keep it for the next iteration. And in the next iteration, again, X1, we will find L1 for it and L2 likewise. And this is how we find L1 and L2. Then once we find L1 and L2, plug them into fitness function, which is x1 square plus x2 square. We plug them, and that's the result. Now we compute fitness function. That's the fitness 10.9. So this is, we can keep it the best because it's less than the 11. 10.9 less than 11.4 greater than 10.9. So this one we keep it as the best. Likewise, we'll do it for x2. We'll see what we get. U1, U2, this one all randomly given. L1 and L2 is found for the current solution. And here is the current solution. We plug them into the fitness function. It is 10.51. 10.51, it is again this less than the other one. We can keep it, update it for the new best solution. And then we go with the X3. X3, again, X3, we find L1 and L2 for it using U1, V1, U2, V3, this one for L1 and this one for L2. Plug them in. L1 is found, L2 is found. Put them into updated equation for the movement of position. So we found the fitness is 23.54. Now here are the solutions, and this is end of iteration. And you see the fitness function kept minimizing, coming down. So 10.51. That is more or less about how to use Cuckoo Search modified version without Lévy, sorry, with Lévy in this class, in this tutorial class. If you have any problem, this is my site. You can, if you want to get further information, please feel free. Thank you very much and stay tuned for the next class.